So what is the limit of sine x over x? So if we take a look at the tabular values of sine x over x, so as the angle x goes towards 0 from the negative side and goes towards 0 from the positive side, you can see that the sine x over x ratio is approaching 1, okay, from both sides. And in fact, if we graph it, which is our most reliable way of doing this, the sine x over x does go to 1. Okay, although there is a hole there, okay, we cannot have 0 divided by 0. Okay, although there's a hole there, as a limit, it is tending towards the value of 1. Now, why is this the case? We can kind of look at this geometrically as well. So, geometrically, if we take a look at the circle, okay, well, what is sine x and what is x? Sine x represents the vertical height, okay, of the unit circle. Okay, this is how we define sine x. That length is sine x. The x represents the angular value, or since we're talking about radians in a unit circle, it represents the length along the arc. Okay, so when we talk about pi, it represents pi along a length of pi along the arc, and that's why we use radians, so we can apply length to it. So as the angle gets smaller, okay, so imagine what's happening to the arc value versus the vertical value as we end up getting a smaller and smaller angle. Okay, now what's happening is that arc value and the vertical value starts becoming more alike. In fact, as we zoom in on a circle, the arc of a circle starts to look straight. So it's just like saying being on Earth, and we know that Earth is round, okay, but we're standing on a very small section of the Earth, a very small arc length of the Earth, and it feels flat. And if it feels flat, then it's basically mimicking this line, sine line, which is our vertical line here. So in essence, as the angle gets smaller and smaller, the curve becomes more and more flat or more straight, and it starts to look more like the sine line. Okay, and thus the sine x over x ratio tends towards 1.